ever stop and think about how everything around us is, well, held together? I mean, from giant skyscrapers and ships all the way down to the chair you might be sitting in right now. It's a really fundamental question, right? It gets to the core of how we build our world. So let's dive in.
All right, so let's just ask the big question right out of the gate. How is our modern world built? I mean, really, what's the secret sauce? What's the fundamental thing we do that lets us create everything from cars to massive bridges?
You know, the answer is surprisingly simple, but it's also incredibly powerful. Our entire world is built by joining things together. That's it, fusing separate pieces into one single strong working thing. And you guessed it, one of the most important ways we pull that off is through welding.
So that brings us right to our topic for today. We're going to do a little introduction to the incredible power of welding. We're going to explore the science behind how we fuse materials together to create pretty much all the objects that shape our daily lives. Okay, so what is welding exactly? Well, at its most basic level, it's a process where you join materials together using super high heat. You melt the parts, you let them cool down, and boom, they fuse together. And the bond you get can be just as strong as the original material, sometimes even stronger. Now, I bet when most of us hear the word welding, you picture sparks flying and people working with metal, right? And yeah, that's a huge part of it, for sure. But it's not the whole story. That same basic idea of fusion, it's also used to join plastics, which is a really critical process for, countless things we use every single day. All right, let's start with the classic, metal. Think about it. To fuse solid steel or aluminum together, you need an absolutely incredible amount of focused energy. So how do welders do it? Let's look at the main ways they generate that kind of intense heat. So, to create that crazy amount of heat, there are really a few key methods. As you can see, you can use a controlled flame, you can use a super powerful electric arc, or you can even use the material's own electrical resistance to generate heat. Let's take a closer look at each one of those. Okay, first up, we've got gas welding. This one is kind of like using a super-powered blowtorch. You use a really controlled flame to heat up the edges of the metal pieces you're joining. Then you take a separate filler rod and melt it right into that gap to bridge the two pieces together. Next, we've got arc welding, and this is probably the one you're picturing in your head with all the sparks. Basically, this method creates an electrical circuit, and an intensely hot electric arc, seriously, think of it like a tiny controlled bolt of lightning, jumps across a gap. It melts both the metal you're working on and the filler material almost instantly, and the result? A really, really strong bond. And last up for metals, we have resistance welding. Now this one's pretty clever. It actually combines two things at once. You've got physical pressure squeezing two pieces of metal together, and at the same time, a powerful electrical current is passed through them. It's the metal's own resistance to that current that generates all the heat you need for the weld, exactly where you need it. Pretty smart, right? All right, now let's switch gears and move into the world of plastics. Fusing plastics, well, it's a whole different ballgame. You still need heat, that part's the same, but the ways you generate that heat can be way more creative than just, pointing a flame or an arc at it. So here are two totally different approaches. On the one hand, you've got ultrasonic welding. This is wild. It uses super high-frequency vibrations to create friction between the plastic pieces, and that friction generates the heat. Then on the other hand, you have the much more straightforward hot plate welding. It's pretty much what it sounds like. A heated plate melts the surfaces, and then you just press them together. And then, for jobs that need to be incredibly precise, there's laser welding. This is some high-tech stuff. A super-focused beam of light provides all the energy. It heats up a very, very specific and small area of the plastic, which creates a really clean, strong weld without messing with any of the material around it. Okay, so we've talked a lot about the how of heating things up, right? But that's really only half the story. Just as important, maybe even more important, is the where. I'm talking about the physical way the pieces are arranged when you join them. And in the world of welding, this is called the joint configuration. And here's the crucial takeaway on that. You could use the absolute best, most advanced welding technique in the world. But if the parts aren't arranged the right way for the job they need to do, that weld is gonna fail. The design of the joint is absolutely 100% critical for strength and durability. The most basic setup is what's called a butt joint. It's exactly what it sounds like. You just place two pieces edge to edge and then weld that seam right down the middle. It's super simple, you see it all the time, but because the weld is only on that one thin line where the edges meet, it also tends to be the weakest kind of joint. So if you need more strength, what do? Well, you can use a lap joint. Instead of edge to edge, you overlap the two pieces. And by doing that, you just dramatically increase the amount of surface area you can weld. It's simple geometry, and it makes for a much, much stronger connection. Then there's the T-joint, and again, it looks just like the letter T. You have two pieces meeting at a right angle. Now, the interesting thing about this one is that its strength is directional. This joint is really strong if you push or pull on it in one direction, but it can be a whole lot weaker if the force comes from a different angle. And honestly, the list just keeps going. You've got corner joints for making things like boxes, you've got edge joints, and then there's a whole family of super specialized joints designed just for welding pipes. And those have to be unbelievably strong and durable because they're handling all that pressure. So, okay, we've gone through the different methods for metals and plastics, and we've looked at all the ways the pieces can fit together. So, what's the big takeaway here? What's the main point of all this? Really, it all comes down to this. A good, strong weld is all about making the right choice. It's a science of matching things up perfectly. You have to match the right heating method to the right material, and then you have to match that to the right joint configuration for whatever stress and strain it's going to have to deal with. We've only covered 6 of the most common joint configurations here, and believe me, this is just scratching the surface. But you get the idea. Each one is like a specific tool for a very specific job, and they're all designed to make our world stronger and more reliable. So I'll leave you with this final thought. Just for a second, look around you. Right now, look at your desk, maybe a lamp, the building you're in, a car outside the window. Now that you know what you're looking for, how many welded objects can you actually spot? I guarantee you're going to start seeing these crucial hidden connections absolutely everywhere.